So hello, welcome to our webinar Wednesday. I'm Dirk Duven, one of the product managers of Biozyme Scientific. We are very proud that so many people, customers and curious scientists join our webinar today. Thank you very much. The aim of Biozyme's webinar is to transport new and exciting information about laboratory technologies and new products to all interested people. Today, I think we have again a very important and interesting subject. Shield scientific gloves, selecting the right ones for your safety. We are very happy that Jens Wagschall from Shield Scientific presents us a better insight into this exciting theme. Jens is a specialist for gloves with a lot of knowledge of glove standard specifications, selection and guiding to choose the right glove for different applications, and several other aspects around lab and clean room gloves. At the end of the session, we will have about 5 minutes for discussion. Please type your questions via chat into the system whenever you like. We will answer them at the end. Thanks in advance for your input. So Jens, I hope you're ready to go. So please give us an insight into your session. Thank you very much.
Thanks a lot, Dirk. Thanks everybody for having me. It's a pleasure to be here and tell you a little bit more about our gloves and gloves in general. First off, I would like to introduce the company Shield Scientific, just in brief. As the name already tells, Shield, it's already, it's in the name. It's all about hand protection, and scientific, it is all about laboratory and high technology sectors. We are a relatively young company. The company was established in 2007, and it is located in the heart of Europe and the Netherlands. Our target market, the most innovative and clean manufacturing market, as written, as you can read here. So we are mainly acting in the clean room or in the lab market. And we are purely and really purely concentrating on the hand protection. So we do nothing else than gloves. And we do focus on our customer needs, and we do actually work with master distributors only, which means you can buy our gloves only with our or at our partnerships, like for instance Biozyme in Germany. So when introducing the gloves, when choosing the right gloves, you can actually do this from our point of view in just 4 steps. Unfortunately, the first step is a little bit boring, but we have to go through it. You have to go through the regulations and the norms. Secondly, I will guide you through a little bit about protection, personal protection or product protection. Very, very important for the most end users is for sure the comfort. And last but not least, for the most buyers, also quite important is the price. So let me please introduce first off some regulations. There are 2 very important stages in the regulatory process. First off is you have to register your product. You have to register it according to the CE. This gives you the authorization to market the product within Europe, and it is compulsory. Otherwise, you cannot sell the product, and therefore essential for us. But primarily, it's just an administrative procedure. The second step is a standardization. So we want to standardize the product so that you compare apples with apples. You can compare the performance, and it is not compulsory. But although it's not compulsory unless required by the user, it is meanwhile requested by all the users, and therefore it's more or less for us also compulsory, because we want to give you a product which really complies to the latest and actual standards. Within the registration process, we can, or the employer has one really big obligation, and this is you have to protect the employee. This means that all gloves being used in a lab or in a clean room, they have to be a PPE, a personal protective equipment. For us as a manufacturer, we have three options. We can either register our gloves as a pure PPE, so the glove should protect the wearer. We can also register this as a medical device. That means it should not, or it will not definitely protect the user of the glove on the risks, but it will protect the patient. Or what we can also do is we can register it as a PPE or an MDD, so you can use it either when you're in contact with a patient or as a PPE, as a personal protective equipment. Talking about PPE, you have, as I said, to register it as a CE. And within the PPE, you can register it according to three different categories. First off, you can register it against minimal risks, which is on the glove side normally, for instance, a knitted glove or something which is not intended to protect you against any risks. Or you can use it against irreversible or mortal risk. What does that mean? It is really if you encounter chemical hazards or whatever, which may cause irreversible damages to your health or to your user's health, you have to register it again according to the category 3. Category 3 stands actually for that the glove has to be audited and the manufacturer has to be audited by a notified body. It is compulsory. So the minute you're working with chemicals, you have to use a category 3. And it has to be audited, as I already said, by a notified body. So the 4-digit number you see under the CE mark, in this case it's the 0598, tells you which is the notified body. 0120 stands for SGS, and so on and so forth. Also, the notified body or unnotified body audits the production and quality system used by the manufacturer. So as you can imagine, a certification, or you have to do this by a notified body. The efforts it takes to get certified is much bigger if you use a glove which is intended to protect you against irreversible or mortal risks. So this is just talking about the certification. Now talking about the EN ISO 374. Why do I talk about the EN ISO 374? The minute you're working with chemicals, and even alcohol is a chemical, you have to use an ISO 374 protective certified glove. This norm was changed in 2016. And the main change, or one of the main change, it was issued now, or it is issued now by the ISO CEN, so it is valid in Europe in all countries which acknowledge the ISO. And it's diverted into 5 different parts. So the EN ISO 374 Part 1 basically tells you about the terminology. It tells you about performance requirements for chemical risks. So it tells you about the length, which test chemicals are being used to test the glove, and which pictograms or which marking is allowed or you can use or you have to use. The second part tells you a little bit more about the resistance to penetration. Third part then is the resistance to permeation. This actually has been removed and replaced by the EN 16523 /1 2015, but basically it is no change in the test procedure. 374 degradation, I won't talk about that, and 3745, and this is very important, I think, for the lab market, is also the performance requirements against microorganisms. So let me talk about the first part a little bit. So here you see 18 code letters. Each code letter stands for a special family of chemicals, which are the chemicals, the test chemicals being used to test a glove against chemical hazards. Before the change in 2016, there were only 12 chemicals on this list. You see it from A till L. Now with a new regulation, it is changed up to 18 chemicals. So you basically see here which families it comes from, or it represents, and therefore you have a quite wide range of chemicals being tested or families being tested. But what is permeation? Permeation, per definition, is the chemical goes through the protective material on molecular basis. So it starts with the adsorption. So the chemical goes on the outside of the glove. It is then absorbed within the glove material, diffusion within the glove material, and at the end of the day, there is a desorption, so it comes out. And the problem with permeation is once permeation has started, you can't stop it. So you can't wash your glove and think, okay, it's working, or I can use it again. Really, once you started with or once the chemical has touched the outside material of the glove, the timing for the permeation has started. Permeation is also an extremely complex process, so you really have to take into considerations the glove materials. Do you use latex? Do you use nitrile? Do you use neoprene or whatever? You look at the properties of the chemical. You look at the parameter of the process, which is very important. For instance, I mean, do you work in a warm environment, or do you stress the material? All these things you have to considerate. Also the parameters of the environment. The thickness of the material is one of the major things you have to take into consideration, and there are some others. So all these things influence at the end of the day, the permeation of the chemical through the material. As I said, there are many dependencies. For instance, the concentration of the chemical. For instance, if you take a single-use lab glove, 0.10 millimeter thickness. So our EcoShield, for instance, and you use sulfuric acid at a 10%. So the glove material will resist 480 minutes against permeation. Even with 50% sulfuric acid, 480 minutes. But if you then go up to 95, 98%, the sulfuric acid will go immediately through the glove material. So you really have to look which concentration of the chemical you're using within your process. And the wall thickness for sure. So the thicker a material, the better you are protected. Also here we have a glove with 0.31 millimeter thickness, 0.14 millimeter thickness, or 0.10 millimeter thickness. And if you compare now methanol, you can see the variant goes from immediate breakthrough up to 36. And again, if you see the concentration of the chemical, 99 to 20%, you also have already a nice protection of 65 minutes against methanol. So these are all dependencies you have to consider when choosing the right glove. Well, let's talk about penetration. So we were talking about permeation. Penetration is basically the glove has a hole. This is what it is. So it's not on molecular basis. It's really the chemical goes through the material to seams, pinholes, or other imperfections. For you as an end user, you can judge the quality of a glove or the protection of the glove by the so-called AQL. So AQL, the lower the AQL is, the better you are protected. So in the past, the glove started with an AQL 4.0. You hardly find them in the glove market any longer. Nowadays, most of the glove or lab gloves use an AQL of 1.5. What does that mean? So if you use 500, or if you produce a batch in between 150 and 500,000 gloves, you take a sample batch of 315 gloves, you test them with an air leak or water leak test against pinholes or other imperfections. So with an AQL of 1.5, if you have 10 gloves which shows pinholes, you are allowed to use the AQL 1.5. They pass this test. If you have 11 gloves with pinholes, this is a clearly fail. There are, meanwhile, after AQL 1.5, also an AQL, you often see them an AQL 0.65, which improves already the safety for the worker by about 50%. So you see here you're allowed to have 5 gloves with a pinhole to pass the test, 6 with a pinhole, and you have already a fail again. We at Shield Scientific, we now managed, due to our unique way to produce our gloves, to increase this AQL to an AQL of 0.25, which again means an improvement for the user of over 50%. Here we only are allowed to have 2 failures, to have 2 imperfections within a complete production batch. And if we have 3 gloves of imperfections, this will already be a fail. Important for you to know, there is no AQL 0.00, which means no manufacturer of gloves can give you the guarantee that the glove is free of holes or free of imperfections. And this also is part of the ISO 374.5, so the protection against biological risks. You will see it with this mark on each package. Well, it was this in the past. It will be this one from now on. But it only shows the protection against bacteria and also fungi. So if you have an AQL test, if you have an AQL level which is higher than 2, so AQL 1.5, you are allowed to use this mark on your packaging. But if you, and nowadays it's more important than ever, want to have a glove which is also tested against viruses, and this is part 5, you also have to do a virus penetration test, which is done according to the ISO 16604 procedure B. So there is a virus put under a certain pressure for a certain time against the glove material, and only if you can't detect any virus at the other side, you are allowed to use under. So what does the marking tell us? So this basically is an old pictogram, but it can tell us about the standard, so which standard the glove is being tested to, which pictograms, or it will show the pictogram. Again, this one is an old one. It won't be allowed any longer. And it will show you the level of performance. So for all PPE single-use gloves, you have to use definitely a CE sign with a 4-digit number of the notified body. If you just have a glove in use, which is only using the CE sign, this is not a PPE category 3 glove, just as a reminder. So this is not something you are allowed to use in a lab where you're using chemicals. This pictogram shows you really that the glove is tested as a type B glove against 3 from the 18 test chemicals. And these 3 letters shows you against which chemicals it is tested, and that there is further information. It is a little bit too complicated to do it in a webinar. Last but not least, you also have the sign, the marking against biological risks. So it tells you about ISO 3745 level 3, which would mean in this case it's an AQL 0.65, and the word virus below shows you that the test or the glove is also tested against viruses. I didn't mention that there is also for sure a pictogram and a test procedure against mechanical risks, but in the lab business we hardly witness this. These mechanical risks. So that was just a very brief, a very quick insert about the about the norms and the regulations. But why actually do we use gloves? I mean, first off, for sure, for personal protection, we want to be protected against chemicals, biological hazards, whatever, dirt. But we also want to protect our product, our processes, our environments, whatsoever. And this can be done by quite a few gloves. So which type of gloves we normally use, we find in the marketplace. For sure, single-use gloves, which are made out of different materials. I already mentioned latex. I already mentioned nitrile or neoprene. These gloves can be hand-specific or ambidextrous. Ambidextrous means you can use them either on the left or the right hand. We have protective gloves against chemicals, biological hazards. There are cut-resistant gloves, gloves which should or can protect you against cold and heat, radiation, and so on. And what we also have to have is clean room gloves, so sterile gloves, non-sterile, endotoxin-free gloves, and so on and so forth. These gloves are basically used in clean environments, especially in the pharma industry. So which type of glove should we use? And within the Germanic and within the German market, we also have a so-called TRGS, which is a technische Richtlinie für den Umgang mit Gefahrenstoffen. And the TRGS 401 is state of the art. So it's basically, or you can use it like a law. And this TRGS in Germany clearly tells you that medical disposable gloves that only fulfill the EN 455. If you remember at the beginning, I was talking about medical devices. So this is the standard for medical devices for gloves. But these are not chemical protective gloves. So if you use a surgery glove, and I only talk about surgery gloves, only or complying to the EN 455, you cannot use it in a lab to protect you against chemical hazards. It is not allowed. You also should look for potential hazards which come from the personal protective equipment, like allergy. To talk about accelerators. So as I said, the glove should not harm the user. Very important point, and again, this is only in Germany, as far as I know, as the permeation breakthrough time I showed is depending on temperature. You should really look into your process, into the temperature, and you might, under practical conditions, can only use the glove for 1/3 of the breakthrough time determined in the accordance with the EN 374. And also the frequency of changing the glove is to be defined within the framework of the risk assessment. So the TRGS really recommends at least an hourly change of gloves. So how do we find the right glove? Which are the different steps? So first off, when you look for a glove, for a new glove or whatever, you have to look, what do I want to do with that glove? So where do I use the glove? You have to do a risk analysis. So you have to specify your workspace and the processes. You have to determine the hazards, assess those hazards, and determine actions against those hazards. Afterwards, you have to take the actions and monitor effectiveness. Last but not least, you always have to continue the risk assessment because your process might change, the chemicals you're using might change, there might be different materials for protective equipment being available, and so on and so forth. So you really have to do a risk assessment and then have a look, okay, which material, which glove might be the right protection or give me the right protection for these risks. If you wear the wrong PPE, this might lead really into skin damages or even worse. And I would like to show you what I mean by wearing the wrong glove, in this case the wrong PPE, by just showing a small there we go. So I just have here some water. Within this water I did put in, I hope one can see it, just here, phenolphthalein. Phenolphthalein really as just as an indicator, and I have here just cut off a finger of a high protective glove. It's really, I hope one can see it. It's a glove, very strong, hard glove material, harsh material. This glove normally is intended to protect you very, very good against solvents. What I fill in within this finger, so I basically here we go. Just have to be careful. Just put some in. What I'm using now is just pure sodium hydroxide. So normally nothing which is dangerous for any glove material. So any nitrile glove, any latex glove, normally will protect you very good against sodium hydroxide. And as I said, this glove normally is, or the finger from the glove I was using normally is a very good protection. It's a PVA glove, which protects you very well against solvents. So now we unfortunately have to have a few seconds before we can go back to the presentation. But you will see hopefully within minutes that the sodium hydroxide goes through the material. And you can imagine when wearing such a big, very robust glove like I showed you, you feel protected. But when using the wrong material for the wrong hazards, this will certainly, or this can lead to a serious harm of the wearer. So I hope one can see it soon. Normally you will see it within 1 or 2 minutes. So I think please allow me to go ahead with the presentation. We will have a look in 1 minute or 2 minutes again to this. So again, if you using the wrong glove, this will really lead into dry hands, redness, dermatitis, burns, or even more serious injuries within your for the end user. So as you can see, what might happen if you use the wrong PPE. So the role of the hand protection for sure is, if you have a glove, first off and above all, you have the protection of human beings. So all the gloves, all the hand protection is always intended to protect the human beings. In order to do so, you first off have to fulfill all standards and regulations for the intended hazard. But at the same time, the glove should have an acceptable dexterity and sensitivity and comfort, because what good is a glove is the wearer doesn't want to wear it because he doesn't feel comfortable with the glove. And at the end of the day, the glove has to be an adequate cost-benefit ratio. So at the end of the day, the buyer will come and tell you, well, look, this glove is far too expensive, or well, at least it has to have a good ratio. So what does the end user want to have? He wants to have a glove which cover all needs. So I want to have a glove which protects me well. I want to have a glove that is compliant, hopefully, or sometimes, because it is maybe I have an allergy, I want to have a glove made of nitrile. But at the same time, it should be as comfortable as a latex. And then the buyer tells you, well, a glove, I want to have a glove which is affordable. So, but honestly, this is a wishful thinking, because yeah, in Germany we call this eierlegende Wollmilchsau, and you really cannot have a glove which will protect you against all risks with the highest comfort and so on. So the very, or above all, as I mentioned before, the most important point for a glove is really the protection of the human beings. And it is not the comfort, it is really the protection. If we talk about gloves, we also have to talk about allergic reactions. So mostly known, there are 3 types of reactions. First is a irritant contact dermatitis. So what can happen is that your hand is reacting against the glove. If it is a irritant contact dermatitis, it is well restricted to the area where the glove is worn. So you really see it, or really see the dermatitis, the signs of the dermatitis in the area where the glove was. The second most known, or basically most often we talked about, is the natural rubber latex allergy. Actually, you won't react allergic against natural rubber. You will react allergic against the proteins. And third is the allergic contact dermatitis. This is when you have a hypersensitive, normally against accelerators. So the ideal solution for you to choose a glove is a powder-free glove, a synthetic glove, and gloves free of accelerators, or just using a limited number of accelerators. So, but let me show you again. Now it is through this. So just remember, I was using a very harsh chemical glove, and I just contaminated this glove with sodium hydroxide. It's not even 5 minutes ago, and now you see thanks to the phenolphthalein, how the sodium hydroxide broke through this very good and protective gloves within minutes. So you really have to be careful on what glove material, what thickness, whatever you're using, and you also have to do the risk analysis to really look that you choose the right glove, protecting you against the right chemicals. Sorry, here we go. Okay, So when we're talking about comfort, when we're talking about the gloves, there are many properties you have to look into or take into your considerations. I just mentioned here 3 of the glove materials: latex, nitrile, neoprene, which are the most common within single-use gloves. I will not talk about vinyl. Please don't use vinyl. The level of protection is no good. Vinyl very often used phthalate, so it's very harmful for the end user. So there are many things which are not, let's say, pro vinyl. For a latex glove, really, it outperforms in terms of comfort any other material used for single gloves. So nitrile is definitely much stiffer. Neoprene, in terms of comfort, is better than nitrile, but as I said, latex really outperforms in terms of comfort any other material. All the other things, durability, tear resistance, well, you really have to look what your glove is intended for. As I said, there are many gloves where latex, for instance, is working very, very good. And especially nowadays, where all those nitrile gloves, or where we have a shortage in nitrile gloves, it might be worth looking at least at a latex glove, whether it gives you a sufficient protection against the chemicals, against the risks you're using. Because in terms of comfort, the end user, they will love it. That's for sure. So what does comfort mean? I mean, at the end of the day, comfort is very subjective. I mean, it's very every anatomy is different. Heat is different for any user. It is depending on the glove material. So it is, as I said, if you have 2 gloves and 5 users, you have 20 meanings, which is the best glove. So, but you normally buy comfort at a price, and this is a price is safety. And again, I want to highlight safety always comes first. So comfort is really, well, I wouldn't tell the least, but it's not the first thing you have to look at. So the logical choice to use the glove really, it starts, as I said, with a workplace evaluation. Then you identify your glove candidates and you test those thoroughly. My advice is really don't give the end users 4 or 5 gloves for testing. As I said, if you're using 5 gloves at for 4 different people, you have more than 20 different meanings, that's for sure. So therefore, give them 2 gloves to test the candidates, and better do a retest rather than giving them too many candidates for the test. Then you choose, hopefully, the right glove. But this is not the end of choosing the right glove, because during the usage, please monitor the usage of the glove and their daily routine. Again, within the future, there might be different materials again coming in your workplace. The risks might change. You have different chemicals and so on and so forth. So therefore, finding the ideal glove, you also have to monitor the glove and the usage. So the 4 steps really is, you look for a compliant glove, which is compliant, which is certified according to all the PSA regulations, which gives you then the best protections. Therefore, you have to look into the glove material, the physical properties, length, wall thickness, and so on and so forth. Which are my risks I want to be protected against. These are all the things you have to look into. As I said, then comfort comes. It's not the first point, but don't forget about comfort. I think I already mentioned that. What sense is a glove if the wearer don't want to use it? So it's also a good point or important point you have to look into. And really, really, the last point is the right price. You have to find the right price, that's for sure. But don't choose a glove only by price. Really choose it by the protection you need. So we at Shield Scientific, we try to make you the life very, very easy. So what we invented was really the traffic light system. So here you see all our brands. We have the Shieldskin Extreme, which is a brand purely for the clean room business. Then we have the Shieldskin Chem, which is intended to protect against chemical risks. We have the Shieldskin brand, the orange brand, which is intended to protect for biological risks, but it also gives you already a good protection against many chemicals, and the Eco Shield for general risks. We also have another brand, which is the Duo Shield, which you can use for dual risks. So you can also use when you want to get in touch with patients. And this really shows you also in the day-to-day business which glove you use. So you already use, if you know if you use harsh chemicals, or if you just want to protect against very basic hazards, which glove to use. And you or your HSE department can see really by the color at the beginning which glove he has to use and which glove is the right glove to use. So I want again to thank you all being part of this webinar. I really, it was a pleasure. It was a new experience for me as well. Normally you can see in the people's eyes, so very different form of doing a presentation, this webinar, but I hope you liked it. I hope you enjoyed it, and I hope that I could give you a good insight of some of the glove materials and of about how to choose the right glove. Thank you very much.
So thank you, Jens, for this very interesting presentation. I think gloves is a very complex subject, and I think it was important to have a look to this. And I hope that this presentation gives them more confidence in selecting the right glove for the daily lab work. So in Germany and Austria, you can contact Biozyme for information or quotes. Check our website at biozyme.com or contact our local Biozyme sales account manager. So now we are open for questions. So you can type them into the chat box and we will answer. So there is, for instance, one question asking, can Shield Scientific gloves being used handling cytotoxic drugs?
Yes, for sure they can, but not all. Handling cytotoxic drugs is a very special, and therefore you should not refer to the European standard, which is the EN 374. You should have a closer look at the US standard, which is the ASTM standard, which is much more stringent than the European standard. But we do have several gloves protecting or giving you the right protection against cytotoxic drugs, and as I said, we can prove according to this standard that the gloves protect you right.
So here is another question. It has to do with the length of gloves. How important is the length of the gloves? Normally, it's 240 millimeters, but what would you recommend?
Yeah, absolutely. It does make in terms of protection a lot of difference. Our gloves, our standard, really the standard length for the normal glove intended to protect you against, let's say, not so hazardous materials. The EcoShield glove is already 250 millimeters. We normally recommend not going under those length because I already mentioned the thicker a glove is, the better you are protected, and the same comes with the length. The better the length is, or the longer the glove is, the better you are protected. It's quite simple. Do you think that the harmful material or the harmful chemical will stop after 240 millimeters? No, normally it will go up longer the arm. So for instance, our red glove, which is intended to protect against the chemical hazards, the ChemNeo, already has 300 millimeter length. Same goes for the orange one. So the longer the glove, the better you're protected, to answer your questions. And it should be at least 250 mil, better even 300 millimeters.
Yes, I think this sounds very logical. So one last question. Which glove to use in an RNase, DNase-free environment?
Yeah, I mean, talking about RNAs, DNAs, free environment. First off, you should go for nitrile gloves if possible by any chance, because the higher abrasion resistance. Sorry. Secondly, use a sterile glove to minimize the risk of microbiological contamination. And third, you should use a certified RNase-free glove. So yeah, basically we have tested 2 gloves, really being RNase and DNase-free gloves.
Okay, so I think we now end this webinar. Thank you for joining us, and I hope that you will be part of the next seminar as well. Thank you very much to all guys. Thank you, and have a good day and a good week.
Thank you all. Bye-bye.
Bye-bye.